Good morning, everyone. I'm Charles Ely. This is the fourth presentation on the COMNET modeling guidelines and procedures. Today, we're going to cover the other software requirements. These include some general software requirements specified in Section 3.1. But mainly we're going to talk about the modeling assumptions and baseline building tests in section 3.3. But we'll start with the general software requirements. These are pretty basic requirements. I don't think that many simulation programs or any simulation programs are going to have any trouble with these. The simulation has to be at least on a 1 hour time interval and a complete annual simulation. This requirement's actually in the performance rating method of Appendix G. Have to be able to model weather, schedules, and other parameters on an hourly basis. There's a minimum of 15 thermal blocks and, 50 thermal blocks and 15 HVAC systems. The software needs to calculate and report on end uses. It needs to break energy down by end uses, and at least in these categories here, HVAC, and usually programs will separate that by heating, cooling, fans, so forth. Lighting, both interior and exterior. Receptacles and miscellaneous electricity, water heating, any kind of process energy uses, including commercial refrigeration, and other energy uses that typically pass through the building meter. The requirements of the performance rating method, which COMNET's built upon, require that all energy use be accounted for in the percent savings calculation. So it's necessary that all of these end uses be accommodated. A few other additional capabilities. The simulator needs to keep track of unmet load hours. Unmet, as we discussed 2 seminars ago, unmet load hours are the way that the way that the performance rating method and COMNET keep track of system undersizing. It needs to accommodate hourly climate data, utility rates, including time of use features and demand. This is necessary because of the default schedules that COMNET has. And the simulator also needs to account for the time delay and declination from thermal mass. The simulator needs to account for the change in heating and cooling set points. It needs to be able to model a dead band between heating and cooling thermostat settings. Needs to accommodate temperature drift from, for instance, the transition from setback thermostats to comfort conditions, or when the heating and cooling capability is shut off and then brought back on again. And it also needs to be able to model indirectly conditioned thermal blocks. This would be something like a stairwell or maybe a or mechanical room that has no direct supply of heating or cooling, but instead it's basically heated and cooled by heat transfer from adjacent zones or by air transport between adjacent zones. The thermal loads in each of the thermal blocks need to account for internal loads, including occupants, lights, equipment that are located inside the envelope of the building. Needs to account for building envelope loads, especially fenestration, insulation, absorptance and reflectance of surfaces, and so forth, infiltration, and natural ventilation. The software needs to also be able to model at least the baseline building systems. There's 8 of those with ASHRAE standard 90.1 2007, which COMNET's built on at the moment. There's a couple of additional baseline building systems that will be added for ASHRAE 90.1 2010, which we'll be adding this year. Systems must be able to model heating and cooling, airflow to the zones, including at the terminals to the zones, also at secondary systems, which would be, for instance, the fan coils, and then at primary systems would be the primary chillers, boilers, towers, and so forth. The simulator needs to be able to make adjustments in equipment capacity or efficiency in response to either part load or temperature, or other factors. So that's what we call equipment performance curves. Needs to be able to model economizer control, because economizers are required by the baseline, by most of the baseline systems, and also heat recovery, both on the air side and water side. Again, some of the baseline systems require this. The COMNET building descriptors are we're going to cover in subsequent seminars in great detail, but they're organized in 4 categories. There's compulsory building descriptors. What this means is that you must always specify the building descriptor. That you can't really have a model without specifying it. Then there's required building descriptors. These are required to be supported by the software, but they may not be needed in every model. The compulsory. Then there's optional building descriptors. These would be features that would not be a part of the baseline building, but they might be a part of the rated building. And in these cases, some of them are optional. And then there's what we call unsanctioned. This is a term we took from a previous ASHRAE document, and this just gives software developers the ability to add building descriptors as they need to support features that we don't really anticipate, or we haven't included yet in the COMNET guidelines. Each of these input types, compulsory, required, optional, or unsanctioned, can have there can be restrictions on their inputs. In some cases, the input might be prescribed. An example of this would be if you're doing tax credit calculations, the schedules of operation are prescribed. So are the plug loads, the occupancy levels, and so forth. There could be a default, which means that COMNET provides a value that you can use, but if you don't want to use that, you can use a better value that suits your building better. There's other restrictions, which we call a critical default, and these will be covered more when we review Chapter 6. But a critical default just means that if you override the default, you need to provide some justification. An example of a critical default would be plug loads. Plug loads should generally be the same between the rated building and the baseline building, but we have a procedure where they can be different, and you can take credit for reductions in plug load. But when you override that plug load default, you would need to provide some documentation and justification. There's also some data validation requirements. These are just some basic checks within the software that the data input by the user is consistent and valid. And there's some simple rules for checking for that. I mean, for instance, a window located in the wall can't be bigger than the wall. They're pretty simple rules. Okay, then moving on to section 3.3. Last week when Mangesh covered the standard 140 test, he mentioned that we had both quantitative and qualitative software tests. These are the qualitative tests that I'm going to be talking about today. We've identified 6 prototype buildings. They're very simple models. I'll show you here. This is we have SketchUp models of them. There's 3 basic office buildings, 1-story on the left, 3-story in the middle, and a 20-story here. If you look at a section through these buildings, you can see that there's a plenum between the floors. And what we want to make sure of is that when you model these buildings, that the baseline that's automatically created by the software will be correct. Also, that the fenestration types, insulation levels, equipment types, and efficiencies are all correctly specified according to the baseline modeling rules. There's also a couple of other buildings. There's model B1, which is a simple 1-story 5-zone building, and model B1 and then C1, which is kind of a larger version of it. These would be modeled as, the B1 would be modeled, for instance, as a supermarket or a small commercial store. C1 would be modeled as big box retail or as manufacturing and so forth. And then there's the 6th model is a bit more complicated. Those of you that are familiar with the ASHRAE User's Manual may recognize this model. It's a mixed-use building. It has a level of parking underneath. There's retail on the 1st floor, offices on the 2nd floor, and then there's 4 levels of dwelling units above there. Here's a section through that model where you can see how it's laid out. There's a light well providing light and ventilation to the so we're providing for the software developers' use these SketchUp files. That's what I'm looking at now. So if the software developer has the capability to import the geometry from SketchUp files, it would save them a little time. But of course, these models are so simple that it wouldn't take very much time to create them in any event. All right, let's go back to anyway, we have identified 29 qualitative tests that need to be provided, and they're listed in this table. This is if you have your, so for instance, there's 29 runs. The first 20 runs test to make sure that that green building, we call it points here under purpose. It probably should be green building ratings or something. And you can see that the first 5 runs use prototype A1, the next 6 through 8 use prototype A3, 9 through 11 use prototype A20, and so forth. We also model these in 3 climate zones, Chicago being a rather cold climate, Miami a hot, humid climate, and Denver a dry climate. And these the climates will enable us to make sure that the economizer requirements are correctly specified in the baseline building. We specify the occupancy of the building, the lighting power, the equipment power, and the HVAC system for the rated building. And then in the last schedule, we indicate whether you are to use the COMNET defaults for schedules or whether you can use another schedule. And then this is an example of the kinds of things we would look at through these qualitative tests. For all of them, we would make sure that the correct baseline system HVAC system is specified, and we would check that the economizer's there, that the primary heating and cooling, that the primary and secondary HVAC systems are sized as they're supposed to be. Basically, we would make sure that we call it envelope substitution, but that means that the baseline building has the right construction assemblies, fenestration area adjustment. Some of the 20-story building has too much glass, so it's going to have to be reduced down to 40% in the baseline building. Baseline lighting, other prescribed modeling assumptions. And these are just examples. There would be other things we would look at as well. So the purpose of these 29 tests are to verify that that the correct modeling assumptions are specified, and also that the baseline buildings are correctly created. So with that, I'll end the presentation, and we'll have a few minutes for comments and discussion.